This video has been created by Great IT Courses. It's a part of a mathematics course that will teach you mathematics step by step from basic algebra all the way up to calculus. For more information or subscribe to the course, please read the video description. Thank you. So in this video we want to know how we can set up a linear equation to solve a real-world problem. In the previous video we did an example of this, but in this video we want to do it in a more formal way. So in order to set up a linear equation to solve a real-world problem, first of all you need to what's important is that first you need to read the problem, whatever it is, and understand the problem. A problem not understood cannot be solved. That is the first point that you need to understand. So first you need to understand what your problem is, and whenever you're solving a problem, if it's a simple problem, for example, let's say a car, you want to rent a car from a car agency, and the car agency tells you that we charge you $50 for the whole day as a fixed cost, and for every mile that you drive the car, we're going to charge you an extra 10 cents. So this is something simple that anyone can understand. But let's say you know nothing about chemistry, for example. You know nothing about chemistry, and so in the domain of chemistry everything is just expressed or thought about in chemistry terms. So if you don't understand that domain, the domain of chemistry, then if somebody gave you a problem, be it a very simple problem in chemistry, and supposing that you know nothing about chemistry, then it's just that you're not able to solve that problem because you cannot understand it in the first place. So that is the first thing to understand. The second thing, once you've understood the problem thoroughly, then you need to define the known quantities in the problem. For example, let's say again the car agency example, the car agency tells you that we charge you $50 for the whole day. For the whole day as a fixed cost. So that means that if you take the car, whether you use it or not, whether you actually drive it or not, you're going to have to pay this $50. And so then the car agency also tells you that we are going to charge you 10 cents. I'm sorry. Let's write 10 cents as $0.1, let's say. So we're going to charge you 10 cents per every mile driven, per every mile driven. So 10 cents for every mile per every mile driven is a variable cost, and that basically means that if you take the car, the fixed cost is $50. You're going to pay that whether or not you drive the car. But for every mile that you drive the car, you're going to pay another extra 10 cents, and that will be added to your $50. So now in step 1, in this example, I'm going to define the known quantities. My known quantities are let's say 50 and 0.1. These are the known quantities. Now some of these quantities are going to be processed by you in some way or mixed with other things, but then those are the next steps. So now define the unknown quantities and define them as a variable as the second step. Now when you rent a car, you don't know exactly. You might have an idea of, for example, you might say, I want to, for example, go from this place to this place first, and then I'm going to go to the other place, the second one, and then the second stop is going to be here. I'm going to stay here for, let's say, 2 hours, and then I'm going to come back to the car agency. So this is going to be a displacement of, let's say, I don't know, 60 miles. So if it's going to be 60 miles, then you have, but this is just an approximation to the actual displacement that you are going to have. So but you do not know but the point is, you do not know exactly how many miles you're going to drive the car. So this is actually going to be a variable in this problem. And the way to figure out this kind of variable and mix them with the data that you already have is that you could think of this as, you could say, for example, if I drive the car for 1 mile, then I'm going to write this as 1 into 10 cents or $0.1. So the variable cost, then it's going to be 1 into $0.1, and this is going to be dollars. If I drive the car for 2 miles, it's going to be 2 into $0.1. If I drive the car for 3 miles, it's going to be 3 into it's going to be 3 into $0.1, and so on and so forth. So I could define this, I could denote this as n or x or z or whatever you want to call it. It needs to be a variable. So I denote this as x as my variable. And so if I denote this as x, it could be x into 0.1. And so this is going to be equal to actually 0.1x. So 0.1x then is going to be your variable cost, 0.1x. And so then you know how you write your equation. Your total cost, interpret the words as mathematical expressions. Now you want to write your expression. Your total cost, let's denote that by C. Your total cost is going to be your fixed cost, which is $50, plus the variable cost, which is 0.1x, and x being the number of miles driven. So now here I define the variable x, the number of miles driven. So that's how you're going to solve this problem. And then now you have an equation. And it's actually very interesting that you can do a lot of fun things with this equation. First of all, you can calculate many different things with this equation. You can, for example, determine what's going to be your total cost if you drive the car for let's say 40 miles. If x is equal to 40 here, then your C is going to be 50 plus 0.1 into 40, which is equal to 50 plus 40 into 0.1 is 4. So your total cost is going to be $54. If it's let's say if you drive the car for, I don't know, 50 miles, then it's going to be $55. 60 miles, it's going to be $56, and so on and so forth. But the more important thing, the fun thing that you can do with this is that you can actually remember that we learned how to draw the graph of an equation and measure the slope of the graph and the y-intercept and that whole story. So this is where you can actually now use all of those data and all of that knowledge and apply all of that knowledge into this new concept that we are learning now. And that is, let's take this example here and take a new layer here, 32-1. So if my equation is c is equal to 50 plus 0.1x, if my equation is c is equal to 50 plus 0.1x, then I can simply draw the graph of this function or this equation. So I can set up a Cartesian coordinate system just simply like that, and then I could say, okay, so this is my slope and this is my y-intercept, or I could write this the other way around. I could write this as c is equal to 0.1x plus 50, and now you must be more familiar with this with this form of this expression. So now this is my slope and this is my y-intercept. And now let's see what the slope of an equation and what the y-intercept actually mean in the context of a real world problem. Now let's say in this graph, this is 50 on the y-axis, and this is actually now your c, or your cost axis, and this is your x-axis, which is your number of miles driven, as you remember that we defined in the problem. Now 0.1x, that basically means that 1 divided by 10. So 0.11 divided by 10, so the slope of my function is actually 1 divided by 10, and this is, as we discussed, this is your rise and this is your run. And what that basically means here is that for every 10 units of run in the x-axis, you're going to rise 1 unit in the y-axis. That means that your function is not going to be steep at all, and it's going to cut the y-axis at this point. So it's going to be something like this. Even not that steep, but well, you get the idea. So now that is your function here. Now the steepness of the slope of this function tells you how quickly c is increasing with respect to a unit increase in your x value. That means that for every unit that you add to x, how many units you're adding to y in this whole function. Now let's suppose let's take into consideration another example of the same nature, or another variation of the same example. Let's go, you went to another car company, and the second car company told you that, okay, so we are going to charge you $60 as a fixed rate for the whole day. I'm going to charge you $60 as a fixed rate for $50, not 60. Not going to change that. We're going to charge you $50 for a fixed rate for the whole day, and then we are going to charge you, let's say, 50 cents per mile driven. So that would be 0.5x plus 50, not 10 cents but 50 cents. Now this function would be exactly the same thing, basically crossing the y-axis at the same point 50, but this time the slope of this function is basically 5 times the slope of the function that we had before, and it's going to be, for example, something like this. So now you can simply see that you can simply compare the two functions, and you can see that the second function, the red one, is getting the value of c here is getting larger and larger much too quickly. The value of c is getting larger and larger in a much faster rate as compared to the function in white. For example, let's say the number of miles driven is 50 miles here. Let's say I basically drive the car for 50 miles, and now I want to calculate the cost in the first car company and in the second car company. The number of for 50 miles, if I drop a perpendicular to the y-axis somewhere around here, let's say this is 50 miles. If this is a perpendicular to this point 50 on the x-axis, you can see that this perpendicular cuts that second function over here and cuts the first function over here. It means it basically means that in the first 50 miles, my first car company has given me this value on the y-axis, and the second car company, which was the price was a little steeper over here, or at least 5 times the number of miles driven, the price here, and then the number of the second function is basically over here on the y-axis, and this is basically this length on the y-axis is the difference of the cost between the two companies. And then now I go to a third car company, and they tell me that, okay, so we are going to charge you $50 for the day, for a whole day, and I'm going to charge you $1 per mile driven. That would be x plus 50, 1x plus 50. And then that would be simply a function like this. That would be basically 5 times the slope of the second function, something like this exactly. Let me see. So that would be a function something like this. And so for the same 50 miles, I would get this value over here, and this would be the highest price that I would have to pay among all the 3 companies that I went to in order to actually rent a car. So that's basically how the slope of a function is interpreted. And one more thing I could tell you about this function over here. Now that we have talked about all this, you can see that I'm running out of time here. So you can see that all of these functions started at value 50 on the y-axis. That means that the y-intercept of all of these functions were 50, and that basically means that the value of your cost function is basically starting with value 50. So that is the whole thing, and thank you for your attention. I'll see you in the next video.